This is an original question. Pretty sick. Haven't seen this before in past years. Number one, state what is meant by a gravitational force. Well, I gotta think of Newton's law, can think of F equals to mg or F equals to original gmm over r square. Sure, any of those. So you can say, if it's just a 1 mark question, you can just say it's a force between two masses. And there it is. So gravitational force. Or you could say it's a force acting between two masses lah. Sure lah, acting. So this is about 1 mark, so 1 independent mark by itself. Okay, let's go to the fun part. A binary star system. Binary means 2, so a 2-star system consists of 2 stars. Wow, they told you the obvious. Okay, in a circular orbit, each one has the orbit of each star in the system has a orbit of period rotation t. Oh, observations are represented in figure 1.1. So if you sat in a telescope and observe the stars over the years or many years, then you would see like, oh, at first it's like that, then it rotate this way, rotate down, and rotate up. And notice how the pattern repeats. So 1 full cycle, it goes from there, 1, 2, 3, 4, 5, and you're back to original position. So it's kind of like, if you want to hope this GIF floats, it's something like that. Okay, you're just zooming across each other, just rotating. Yeah, pretty much it. That is what a binary system does. Kind of does a little... They dance around each other. Very nice, very pretty. Okay, anyway, let's see what they want us to do with this system. Observe from Earth, the angular separation is very small angle. Okay, the distance of the binary star from Earth is a very big distance. Show that the separation of the centers is this. What do they mean? Oh, well, I guess you could redraw this whole thing down here. Give me a second. So give me a second to draw this. Yeah, I'll try to draw it. So the angle is pretty small lah. It's not so big, but this would be the angle and between the planet. So star 1, star 2, and the angle is very small. So the arc is pretty much the straight line between these two angles. Okay, so I'm just kind of showing you, okay, if angle small, you can say that the separation D is the arc length S. If you're looking at a cone, or sorry, not cone, a vector, a sector, sorry. So this one here is the angular separation theta. This one is R. So we are Earth, our eye is down there. We are looking at how far apart, angular separation. So let's use our equation S equals R theta. Only 1 mark. Okay, lor. So D equals to R. What is the R? R, distance. 1.5 times 10 to the 17 times the angular separation in radians. So that will be 1.2 times 10 to the negative 5. There we go. So we press our calculators. We should get 1.8. Where am I? Times 10 to the 12. Okay. So this one's only 1 mark, so you don't get much. You show the working, you should be good. Okay. Now comes the interesting part where we go into circular motion. The stars rotate with the same angular velocity about point P as shown. Point P is what we call the center of mass lah, for the whole system of 2 stars. Anyway, we don't need to know that here. But the period of rotation is 44.2 years, so this is T. How long it takes for them to do a complete cycle or dance around each other and come back to the original place. Calculate the angular velocity omega. How would you find the... Do we know the period? Oh, we do know the period, so we can count omega. So we need to recall a little bit, either from simple harmonic motion or this chapter, circular motion. Omega is how long the angular velocity, how long it takes to go 1 full cycle, which is 2 pi. So we're going to do 2 pi divided by... Do we put 44.2? Hang on a second. This is in years, my friend. And look what they want down here. Radians per second. So we need to convert years to second. So we could say 44.2 years is 365 days. I know you might argue, Miss, it's supposed to be 364.5. It's okay. Just 365 days per year. Times, so each day has 24 hours. So you multiply by 24. So convert that to hours. And each hour has 3,600 seconds. So you have to multiply all these things here to get your final answer of 4.5. This one I calculate already. Times 10 to the negative 9 radians per second. Okay, can write that here. 4.5 times 10, negative 9. Be very careful. Remember to convert your years. How many marks is this? 2 marks? Okay, if you know this and you got your final answer, you will have an accuracy mark and you will have an equation mark to show that you understand what angular velocity is. Next, this is where things get a bit strange. But don't worry, they give hints. So by considering the forces acting on both stars, show that the ratio of the masses is this. Wow, how do we start? Well, they did say something very important. They said by considering the forces acting on the two stars. What are the forces acting on the two stars? Let's go back to the picture here and draw a little bit more on this thing. So if you have the masses like this, or what is the force acting on them? You can say, oh, miss, there is one gravitational force. This is force by 2 on 1. So the tiny star will pull the big star to the left. How do we know that? Well, this is our good old F equals to GMM over R squared. Or I should say D squared. How far apart they are. And on the right side, you also have the same magnitude of force, and this is the force by star 1 on star 2. And both have the same magnitude, equal opposite direction. Okay, so this is F12 equals to negative F21. Newton's third law from AS, remember? So that is one clue that we know that both of them would have the same force acting on them. The other method is to think about centripetal force, but never mind, let's write this one down first. Okay, so we know the forces on both of them are the same. How do we find ratios? Let's not panic and start writing about the forces first. Okay, so fact number 1, we know the gravitational forces are same. Well, gravitational forces on both the stars are the same. Hence, what we can say about the centripetal force? We can say that the centripetal force is the same for both of them. Now this one, if you find not convinced, let me show you. So how do you know the centripetal force are the same or not? Let's go, for example, on this one. You know the center of the center of masses is here. So if I look at the star 1, it's going to experience some force Fg. Okay, then when it moves to the right already, the center is here, right? It's still experiencing the same Fg thanks to the small mass. Okay, so this Fg acts as the centripetal force for the big star. So I'm going to write a reminder here. This is Fc. This is the centripetal force for S1. If you want to go on, I can go on some more lah, okay? If you want to look at the force onto the small one, this tiny fella will also experience the same Fg. Pointing to the center, okay, that's your centripetal force. Then here, same as the purple Fg. So you can say this is the centripetal force for S2, which is the same for both. So Fc here equals to the purple Fc. Same, everything same, so you can equate you choose whatever equation you want to equate. I think here, let's try equating the centripetal forces of both of them. So for the star 1, so force centripetal 1 equals to force centripetal 2. This one will be, let's see, what shall we use? Mr omega. Reminder, F equals to Mr omega square. Okay, let's use that. So M1 R omega square equals to M2 R omega square. What is the R? Are they the same? Scroll back up. R is going to be the distance between the center to the middle. So this will be the R for number 1. Because it's going to rotate about the point. Okay. How about for the other fella? This will be the R, the orbital radius for number 2. Orbital radius. Remember, you have circular motion like this. Okay. How far are you from the center? That's what you're going to be. So R1 is X. R2 is D minus X. So let's write that down somewhere here. R2 is D, the whole distance, minus X. Okay, let's go down and write it in. Where were we? M1 is R1, so that would just be X. Is that X? Yeah, R1 is just X. X distance away from the center. So X omega square. M2, this one will be D minus X, right? Okay, so we write there D minus X times omega square. But also notice that both of them have the same orbital period. So omega and omega, you can divide it out lah. Because omega is 2 pi over t ma. We already found the angular velocity already. So it's the same for both. So you can pretty much divide it out. So this is gone. So the next step is you rearrange M1 divided by M2 equals to D minus X over X. Yay! So you found the answer. Wow. How to find this? Wow, this is one method, okay? This one will give you 2 marks, the shortest way. The first mark comes from you knowing any of these facts and applying it to get your final answer. You know, this whole step here and here, A1. If you're wondering, why didn't we use fact number 1 to do this question? You can try, but you realize everything will just cancel out because it's the same force. Okay, so we need some difference, and that's why we use the second method where centripetal force is the same. Okay, let's move on. So they give us an interesting equation now. Well, you can guess where it came from. Looks very familiar, right? So the mass of star 1 is given by this expression. The ratio in number 2, so this ratio, is 1.5. So M1 over M2 is 1.5. M1 over M2 is also D minus X over X lah. So might also write everything here. Use the data from B. What is the data from B? Remind yourself. Angular velocity, 4.5 times 10 negative 9. Or is it this one? D, this one. The separation distance. 1.8 times 10 to the 12. Sorry about that. So this is distance 1.8 times 10 to the 12 meters to determine the mass M1. Let's try to play around with the equation. So GM1, I'm just going to rewrite the whole thing. D square D minus X omega square. Do we know all the information? M1 we don't know. D we know. X. Do we know X? What is X? They didn't really give us X, right? No, if we look back. Moment of panic. There is no X, miss. How to do? Calm down. You haven't used this piece of information yet. 1.5. We're going to use that. Don't forget. Don't forget. You can use that here. Anyway, let's continue first. So, let's plug in whatever we know here. So 6.67 times 10 to the negative 11. Mass 1, we don't know. We're trying to find that. Okay, what's D? D, we calculated earlier, is 1.8 times 10 to the 12 meters square. Okay. Then this D again. Okay lah. So D, 1.8 times 10 to the 12 minus X. This is where we got to pause a little bit and say, okay, we're going to sidetrack and use this. So we know 1.5 is D minus X over X. 1.5X equals to D minus X. Okay lor. Then can simplify some more, right? So you can say 1.5x plus x equals to D. So you know that D and x are related through this relationship where D is 2.5x. Done. Or I guess you could say x is 2 over 5D. Just rearranging a bit lah. So here you'll be 2 over 5. Wow, how to write here? It's not enough space. Times D, which is 1.8 times 10, 12. Actually, we could have done some calculation to simplify this a little bit more. It's a bit long. But oh well, we already wrote it out. So the last one is omega. So previously they already asked you to find that. So we just write that down. 4.5 times 10, negative 9 radians per second. A bit slow, negative 9. Okay. With this long thing, gonna press the calculator. And should get something very close to... Oh wait, I just realized an error. Here should be omega square. Okay, so I should get 1.06235. Anyway, just leave that as there. Wow, very big oh, very heavy oh. Planet Mars, star Mars, sure, Mars will be very big. So my final answer, I can do 2SF times 10 to the 30. How would I know 2SF or not? Nah, I see lor. The least SF is 2. I think it's 2. 2. Okay lah, 2 lah, 2. Although this one got 3. But okay. So that is how I can find the mass. Wow. Where do the marks come from? There are 3 marks for this question in total. The first one comes from you knowing how to use the ratio. Wow. Do you get a ratio x equals to something d in terms of d? The next mark comes if you know how to plug in everything correctly. So this long thing. If you can factorize stuff, please factorize lah. It's a bit long. And press calculator correctly, you get the last mark. A1 mark for this whole thing right here. Okay, wow, that was quite a fun thing. So I think that's the end. Yes, that's the end. Wow. This one, you might get stuck the first time you do it, but you stay calm and try to see how you can apply the things that you have learned for this question. Okay, so that is all for this past year question. I will see you in the next one.